Okay, but first today we are going to finish soldering our kits, and then we're going to do some initial checks on them. So first, one thing that we're going to be working with the soldering iron today, and one important point that I keep forgetting to mention is, to do your best to turn off your soldering iron whenever you are finished with working with it. And it's so easy to get caught up in, finishing up something and then you forget about it, and then in the middle of the night you remember about it. And generally it is, as long as you have put it in your holder and it's not touching anything, that it's not going to like catch on fire in the middle of the night. But what can happen is it does degrade the soldering tip, and so you can basically overheat that over time, and you'll have to replace that. But just for peace of mind, I always try to double check that on my way out before I finish what I'm doing and make sure that the soldering iron is in fact off. Let's see. So first, so real quick, just to go back over this, hopefully you guys still have your SkeeterSat assembly manual, so we're still going to be using this today. And then if you remember, there's like a theory of operation on here, and then we were kind of going through all these different components, and then the schematic was on the very last page, as well as the board layout on the very back page. So all of those are going to be important, and certainly today, whenever you start actually putting a battery in and measuring resistances and seeing how well you did at soldering and putting in the components properly.
And just as a reminder, this manual is available on the SBC website under Unit 4.
Yes, very important. Thanks. So, so last time, this was where I was at with the board. Unfortunately, I don't have my computer set up tonight to be able to see what you guys are seeing, so hopefully you're seeing this. This is kind of how far we got last time. One of the things we didn't do was put in this IC chip, so hopefully, I think we'll finish soldering first and then we'll go ahead and put that in. But what I want to do right now is work on the thermistor, because I think that's kind of our outstanding part. So again, if you're not ready for this part, that's okay. You can just watch and then catch up later. But what's important is that you have this liquid tape, electrical tape, that we're going to be using. So hopefully you guys have that, or will have access to it soon. If you also have heat, well, you need this actually to make it completely waterproof, to be able to dip that into those the water and ice and different things that Josh was just telling you about. So in your miscellaneous device kit that was part of the initial solder practice, you might have had some wire. This is just ribbon cable that I have here, but maybe there should have been some length of this in your miscellaneous device piece, and you might have actually soldered it to your practice board. So if you have some other ribbon cable, or any 2-wire cable, you can use it. That's fairly thin, or you can, if you did use it previously, you can unsolder it. So I just wanted to use what I had around. So I'm going to cut off, I guess this is several inches, probably 6 or 7 inches here. So you cut that off. And this thermistor part is a little bit complicated, because we're going to have to splice wires, and that means that we're going to be soldering wires to each other. And so with the board, whenever we're soldering, it's really fairly easy, because the board is in place. Maybe you held it against the table or in a vise, like what I showed last week. But it's a little bit more complicated with wires, because they're kind of dangling around, and you're trying to be able to attach them with a soldering iron. And so we can keep in mind that we're going to, whenever we're looking at soldering wires to other wires, that all of these things can potentially be moving around. So we're going to go ahead and try to secure those. So the first thing about the ribbon cable, if you have any, is that they're attached. But we'll need to first strip the wire. Well, first you need to just cut a little bit with your cutters to be able to get, I'm just cutting right through the center of this.
Ribbon cable is often bound together by a small amount of glue or epoxy that can be easily separated once it's been cut.
Right.
Also, real quick, I wanted to mention the motivation why we're attaching these thermistors to longer wires is, as I mentioned, we will want to be submerging these thermistors in water next week. And if you solder this directly to the board, you don't have a lot of range of motion to get that thermistor into the beaker. So that's the reason why we want to add a little bit of extra wire length to this.
Yeah. So I went ahead and pulled apart both sides of it, just a little bit, like maybe an inch or half an inch on each side. So we'll need all of this. Okay. And then I'm going to get my wire strippers, which look like this. And I'm not sure exactly if this is the same type that you were sent. But I want, for those of you that aren't used to stripping wires, just take a look at it. And what you're going to see are a bunch of numbers. And so starting at the bottom, I see AWG, which is the American wire gauge. And then mine starts at 20, and then it goes to 22, 24, 26, 28, and 30. And then I can read this side. So this is the side I want to use. So the American wire gauge deals with the diameter of the insulation or the actual wire. So as you go increase in number, the wire, the diameter actually gets smaller. And then as you decrease in number, so 20 is a larger thickness of wire than it is for the 30 gauge wire. So just keep that in mind. And you can also take a look at the holes here, and you can see the little semicircles are also exactly what I said, where 20 is going to be larger than 30. So what's important is that you maybe if you have a spool of wire, you can take a look at it and you can determine exactly what that wire gauge is, because it says it on the the spool of wire. But if you don't know, that's okay too. But you can pretty much check. So this is fairly small, but I think, so if I put it in the 20 and try to pull it out, it doesn't really work. But when I go to 22, and basically all you're doing is I'll do this other one. So I put it in, and then I have on the opposite side the amount that I'm interested in stripping. And then I close it, and then I pull, and the insulation comes off, and you're left with only the braided wire that's on the other side. So what's easy for people to do, and a big mistake that people make, is that they just kind of grab the wire strippers and then just kind of strip at a random number. It's like, oh, it works. But what happens is if you strip this too small and you were to inspect the braids, you would see that if you were to strip this at too small of the hole size, that some of these the braids, some of these individual strands of wire can be nicked or cut. And if you look down and you see that you have nicked or cut any of these individual strands, you need to redo it. So in that case, so say that I did make a mistake, I would cut it off, try to cut them even, and start over and do it again until you find the proper hole that does not cause any of your individual strands of wire to break. So the reason why that's important is well, first off, if you are losing individual strands, then you've cut down some of the current carrying capability of these individual wires. But also you cause a lot of mechanical damage to this to the individual wire, to the whole wire bundle that will break eventually. So yeah, it's just real important to keep that in mind. So I'm going to go ahead and just strip both sides here. So again, for my ribbon cable, I'm using 22 on the wire gauge here to be able to strip it. Okay. All right, so if you pull out your Mr. packet that we gave you, there was 2 of them here. I have one is left for me. I've used one to practice on before I'm showing you here today, so that's where it's going. But fortunately, there's two of them. So if you make a mistake, you can solder the second one. All right. So I'm going to go ahead and remove this. So this is my trick too, by the way. You can actually do the, I'll go, instead of using a box, sometimes I use a cardboard box like this to kind of get it up so I'm able to solder, but I think you can also do this on the whatever mat you have. Although if you do have a mat, the problem is that it will, if you put your soldering iron to the mat at all, it could potentially burn the mat. So maybe you can find a piece of cardboard or something like that. That way you're up and protecting it. And then what I'm doing is I'm adding some tape here to be able to protect the box that I'm going to be using. Also, this is just my way of doing this. I think there's a lot of different methods people use to splice wires, and you might have a vise or the helping hands. So any of those could also assist in this. So you can certainly be creative. A vise that is not showing up properly, but that's all right. Any of those would also help in this case. So I'm going to go ahead and remove the thermistor. I like to have it facing towards me. And I'm putting that thermistor on here. And then I'm taking my tape. This is just the same kind of tape you use for your parts inventory. And then I'm going to secure it right here. And then this allows me to lift up these wires and kind of control them without trying to hold the thermistor in my hand. And I did have, apparently there's two different thermistor types. There's might be a blue one that you have. This is with the blue wires on it. This is red wires. So apparently the blue ones are a little easier to solder to than this one. This one certainly gave me some trouble earlier, so don't feel too bad if you have problems. You might have to try it a couple times. Okay, so the first thing I'm going to do is go ahead and turn my soldering iron on. Just get a little closer here so I can see what I'm doing. And since I'm looking down, I'm not able to really monitor the chat. So if anybody has anything real important to say, you might just chime in and ask me the question, because I might miss it. All right, so first thing I'm doing is, of course, I have a wet sponge that I am cleaning my soldering iron. And it's really important for this because, like I said, this is already pretty difficult to solder. Okay, so hopefully... All right. Okay, so I'm gonna, it's what we call tin the wires, and that just means I'm adding just some solder to it. And probably not much is really gonna stay on here. Okay, and then I'm also gonna tin these wires as well. So I'll try to do that in here. Actually, before I tin these, I might try, I'll go ahead and tin them. We're going to eventually need to wrap these around. So how am I holding this? I'm holding this like this. So that is, I'm holding the bottom wires with my pinky fingers, and then I'm holding the solder with this, so that way I can kind of feed it. That's how I do it. Again, there's many different ways to do this, so feel free to try anything that works for you. Again, I'm just tinning the this wire here, putting just a little bit of solder on it. And what this does is it's just going to bind those wires together. So now it's kind of like I had multi-strands, and now it's a much more, it's just a solid core for me to work with. On top of having solder on, that eventually needs to bind to the wire right here, to the thermistor wire. Okay, so earlier when I did this, I was having a little bit of problems with this sticking. So whenever I just solder directly, I'll give it a try here just so we can see. I just didn't feel it was a very good, strong mechanical connection. Again, I'm holding it there. Yeah, it's just not sticking. So let's see. I'm also going to now tape this down too. Oh, by the way, the thermistor is not polarized, so it doesn't matter which wire you solder what side to. You can do either. That's why you kind of see me turning it and not really paying attention to that too much. All right, so let's see if I can. This is one of those things that if you, you know, were soldering thermistors every day, you would have like a great process for, and would be able to have probably a better way, a more secure way than maybe what I'm doing here. But whenever you are first starting out and you're like, how do I solder that? You just kind of have to try some things, and hopefully you have extras to, that way you can make mistakes. So what I'm doing right now is I'm taking the pliers and I'm just wrapping the the black and white wire into a loop around the thermistor wire. So that way they're kind of interconnected and it makes like a little hook. So now there's a hook there. Okay, so I don't know if that's, let me try to zoom in on that. Okay, so maybe that's clear that there's a bit of a hook there. All right. Now that hook holds a little bit of that solder, and it's much easier now to do this. And you can also see I'm not having to do anything weird with my hands or whatever because I've got both sides of this secure. And the reason I'm not doing it in my vise is because these wires in the vise, it hangs, the wires kind of hang out, and it's really tough to sort of do all this together. So this is really nice to be able to have something secure here that allows me to do it. Again, I think if you do this directly on your solder mat, you will definitely burn through it. So you need to have a piece of cardboard, or and then ideally putting that, you really need to put that tape down. That way you're, you know, not going to burn the cardboard box as well. Okay, so all I did was I added some solder to it and let it cool. But you can see because of the hooks, it allowed the solder to sort of form there and allowed it to stay. So let's see how I did. So I'm just gonna, I've let it kind of cool. I'm just gonna kind of push on it and make sure I'm catching all those little edges. Okay, it seems pretty good. Let's see if it's fairly secure when I lift it up. It's pretty good. It's not falling apart right now, so that's a good sign. All right. So now we're going to do the liquid electrical tape part of it. So I'm going to zoom out. Okay, so This is Josh's technique. He recommended this. So get a piece of paper and we're gonna put our box right here. So the liquid electrical tape is liquid. So if you don't have something, if you just put it directly on whatever, it's gonna drop to the ground or to your table or wherever. It's kind of a mess. So you definitely want to do something that will, protect whatever the surface you're working on top of. So I'm leaning it off right here, and now I'm going to go ahead and tape it down. Okay. All right. So again, liquid tape. So we need to apply 2 coatings of this, and you apply it once and then you let it sit for 10 minutes, and then you apply it again and then you let it sit for 10 minutes. And then to actually put this into water, you need to let it sit for a 24-hour period. So for those of you who might watch this next week or something, then just make sure you do the calibration activities after you have let this sit. So when you open this, it's kind of goopy, and it should be a liquid form. If it's like earlier we opened one and it had been sitting for a while and it was it was almost impossible to apply. So hopefully yours looks, it's kind of like, it's more liquid than a gel, but it almost seems like a gel is the consistency that I would call it. And what you want to do is we're trying to basically, you can put these a little closer together, but you definitely want to keep them apart. And this liquid tape is going to protect it from allowing these contacts to the leads to get wet. And I should say that another alternative is to you can sometimes maybe use heat shrink and then use the liquid tape on top of it. And that's an okay thing to do as well if you have heat shrink. But I know that you guys weren't sent heat shrink, so I wanted to do it without show you what it looks like without the heat shrink. So, all right. So you just kind of get some, and then you sort of paint it here, and you want to go over all of those open areas. Yeah, it's kind of a mess. You also want to do it on the bottom, although that's also another reason to do a second coat, is to go back after it dries and make sure you got everything. And maybe yours is a little, it's been a long time since I've opened one of these new, so maybe yours is even more liquidy than this was, and that's great if it is. I think it's fine. Just make sure you're coating all of those open contact areas. Okay, so I'm gonna push this out of the way right now. By the way, this is just a big blob down here. This is not part of it. It's only this section. And I'm going to show you how to solder onto the board itself, the contacts. And by the way, this is an example of how sort of nice it can look. So maybe if this were newer, this person used both heat shrink as well as the liquid electrical tape. So it looks pretty nice. All right, so that's going away. And now I'm going to go back to my board that I started last week. And so there's a couple ways to attach the thermistor. I didn't quite realize actually that maybe what we should have done last week was not install this. So if you did install it, that's okay. I'm going to show you how to solder it. But if you didn't, you can actually go directly into if there's still holes there, you can just go directly on into the holes with the other side, like what we showed you during solder practice. But if you weren't able to do that, then we're going to just work through how to solder directly on here. And another option, the reason why this header is here is if you have that there would be a header connector that would be able to attach here with crimp pin. So if you have that available to you, maybe some of you guys are a little more advanced with that, you're welcome to do that as well. So any method of attachment works. You know, hopefully it's just if we are soldering directly on here, that we make a good solder connection. Okay, so let me fix this. All right, so we're going to be soldering to this pin and this pin, and I see now that this is not ideal. So I'm going to turn this a little bit so now you can see it. Okay, so I'm using my vise again, by the way. So that's what I've got clamped in here. Again, I would highly recommend having, you could put this board flat on your table is an option, or if you have a vise, that's even better. So I'm going to get 2 new wire. Well, actually, this is a thermistor from earlier that I had made the first one. So I'm going to go, so the first thing too, I would say that we need to do before we solder this on the board after you will finish the liquid electrical tape after it dries, is we are going to verify that we do not short anything. So on the other side, let me zoom out, hold on, sorry. All right. And you see me kind of putting my fingers against it. I'm just making sure all of those individual braids are back in the center of the wire before I solder these together. I see there's some chatting going on, so let me just check this real quick. Awesome. Okay, cool. So you guys are chatting. No problem. All right. So the first thing I'm going to, oh, yeah, that's right. We were going to check the resistance and just verify that these 2 wires are not shorted together. Oh, no. All right, so I see there is a resistance here. So I think I'm good. And just remember, this is a thermistor. That means it's a resistor that changes with temperature. So that's why when you measure, you should be able to measure resistance across this and actually see it. But it should not be measuring like anything under 10 ohms. That is a short. Okay, so again, I'm going to tin my wires here. Okay. Okay, so I'm going to go ahead and put some solder on this pin. So you kind of want to goop it on there a little bit. I mean, you don't want too much, but you definitely want to be able to see. So this is the back pin and the center pin. I'm gonna put some solder on there. By the way, if you heat these pins up too much, I meant to tell you this last time, it will cause the pin to, the pin gets really hot and then it starts to melt this plastic piece down here and the pins might slide up and down. So it's, normally it's not too big of a deal if you get something, you keep it a little too hot or keep the soldering on there a little bit long, but in this particular case with these headers, they're pretty sensitive to heat. So now there's solder on me, solder not on me, but on the pins. Let me go in here so you can see it. Okay. So I am heating up the pin and the solder right now, and then I'm just going to hold this wire against there and then let it cool. Cool. Okay. And then I'm going to do the same thing with the center one. Just trying to get those very close to each other. Yeah, there we go. And remember, you got to kind of hold it together while it cools. All right. So hopefully you can see that. So if I had a choice, I would probably prefer to have soldered this directly to the board. But like I said, I didn't quite realize that when I had you guys solder it in the other day. So yeah, if you already soldered the header, it's no problem. You can do this, or you can solder directly in those holes. Okay, so let's go back now and put a second coat of the liquid electrical tape on. So now it's pretty dry, but I'm going to go ahead and flip it around. Again, that part is not part of my blob here. And it looks like I pretty much got those pieces, but I'm going to go ahead and apply a second coat. All right. So I'm going to set this back over here and just let that dry. Okay. All right. So hopefully that's going okay. And again, after we finish, so right now the things that I have left to do is we're gonna install the integrated circuit, and then I'm gonna show you how to clean the board, and that might have to be done whenever you can get some isopropanol alcohol, and then we're gonna work on the initial test with the multimeter. And some of that, I think we can ask Josh, but I think you might be able to do some of those initial tests without having that thermistor on the board. Well, in case you weren't able to do everything tonight. So,
Yeah.
go ahead.
I believe that is correct. I would. It's mostly the components all need to be soldered onto the board. The thermistor you might get some slightly different readings on some of the measurements if you don't have the thermistor installed, but it should be okay. I've always had the thermistor installed whenever I was doing those measurements, so I'm not entirely certain.
Yeah, and I can try to check with this other board too, because the test board we have, I can remove the thermistor on and off. Okay, so last time I did not, I forgot to put the circuit on, the IC chip on, but I would say, you know, typically I would install this after we're done soldering everything, because we have the luxury of doing that with this socket right here. So it's just a good way to make sure you're not damaging the part in any way while you're handling the board or whatever. So this particular chip, it is interesting that there is, I see a circle in the back as well as the dip in the front. So I think that, let's see if I can zoom in on it. Okay. So the dip up here in this case is the side that's going to orient with the part. But if I were, actually, yeah, that is true. If I were still uncertain, because this is actually a little confusing with the way they have it, where they kind of have two different markers here, I would check the data sheet for it. And that's simply looking at this number. This is a, you can look at the schematic, or you can look at, there's normally two kind of part numbers that you might, or string of numbers and letters that you might find. One of them is typically the lot code that is not important, but one of those will be an actual part number. So you could try both of them if you're not sure how to read that. But I think this is the TLC 556CN. So you can literally type those numbers into Google, and then you should be able to find the data sheet, or you can go to DigiKey or Mouser, look in there, and then make sure that you know where the pin 1 indicator is. But I'm telling you right now, because I have a working board right next to me, so I know what the correct orientation is. So you just come in and you will install it. So this particular chip is not quite fitting into the dip socket, so I might have to just lightly, just kind of lightly bend the leads a little bit. It's been a long time since I've installed one of these, so hopefully I'm doing it right. And the photo sensor is really in the way. So it's important here not to make sure you don't accidentally bend any pins, which can tend to happen. So I kind of like to get one side in, and then sort of you can push against that side once you get all of those lined up, and then get the other ones. But just be real careful with it. Just do very light movements. And then you kind of, before you push it all the way in, just check to make sure you don't have anything out of there, because it'll just be or bend the lead. And if you do bend the lead, it's usually not the end of the world. It's something that you might not want if this were like a final part that you're about to fly on the balloon and you did something like that, I would probably take it out and put a new part in because there might be some mechanical bending, but for what we're doing here, just testing, it's probably okay. All right, so at the end, it should look like this. All right. The other thing I want to go over is, before we move on, is how to clean the board. So somebody earlier mentioned that, he had, on the back of the board, he saw something like this. I believe this is what he was discussing. And so it was good to sort of take a look at this and say, what is that? So that's the leftover flux from the solder. And a lot of times you'll pick up boards and you might see this. In general, for like a board like this, it probably will still function with this on there. But the reason I don't like to leave this on is because if you actually touch it, you can see it's kind of sticky. And if your board is in an area that's sort of not the cleanest environment or whatever, you might end up getting little particles on here of dust or something else that sticks to the bottom here, and then you end up with a short across these pins that you didn't intend to do. You try to avoid that with solder, but then you end up doing it just by leaving it out and something falls on here and kind of gets stuck on here. So there are chemicals that you can use for that are specifically for this, like if you had a larger board. But oftentimes I just like to use just regular rubbing alcohol, or I think it's rubbing alcohol, but it's isopropanol alcohol. And I've got a bottle here from the lab that I brought in. So I also get just a brush. Hold on a second, let me zoom out. If you have a brush like this, or even an old, well, I wouldn't use an old toothbrush that has been used because there might be some chemicals on that too, but if you just have a toothbrush, that works as well. Sometimes you see people will cut off parts of these, which I might have to do as well to make it a little bit rougher to be able to clean off things. So I'll try with this, but I may have to actually cut this off. We'll see. So I'm going to try to avoid anything with this speaker, but the alcohol does, and also not damage this, but the alcohol does dry. And so you don't want to turn the board on immediately after you do this, but you give it several minutes to dry, but it does evaporate. So it's a great way to clean it. And so typically I'll just probably spray it on here. Sometimes it's good to do it over a trash can because it's probably going to make a mess right now, but that's all right. So again, tonight, if you're, your board will be fine if you don't do this, but you can do it later if you want to be able to check it out. And you should see, and you can let it sit on there for a second, but you should see that this will clean it pretty good. And by the way, if you're seeing these two pins here, they are not soldered. So I just noticed that. So whatever I did last time, for whatever reason, I didn't finish soldering it. So you might also look at the bottom of your board and before we start trying to turn it on and say, oh yeah, I didn't solder those pins all the way last time I got in a rush and I didn't finish. So when we do the surface mount parts too, this whole problem of maybe, we start using really fine pitch parts. I think or if you were doing some really small signal sampling or something high frequency, whatever, this is, you're going to get this is a way to ensure that you're going to get a good quality signal whatever the board is designed to. You still might have a problem with the design, but at least your board's clean and it's not from dust particles on your board that's causing you to get a bad signal. So, okay. So, let's see, I should have, sorry if I wasn't in focus there. Awesome. Okay, so I'm going to get a little cloth or something here. there's any. Just give me a second. But I'm of course not going to use a paper towel on here. I'm just going to let it dry naturally. So when you use a paper, like just a regular paper towel, it has dust particles and things that will also just get on the board. Sometimes you see people use dusters, like the spray can. That can help to remove dust, but if you have flux on there, then the particles will likely still stick to the flux. All right, so I did it. Sometimes I see that there's like some white. This is why the chemical remover, if you were to use that, doesn't actually cause this white to stay on the board. But sometimes I just kind of do another little wipe and it tends to go away. Okay, so I'm going to go ahead and let this dry, and then I will move on here to the next section so we can keep moving. Okay. If it's still, sometimes it takes a couple cleanings to get it really to get all of the flux off too, because if there's a lot, then it just, yeah, it's hard to remove. But usually I wait again till after all my components are soldered, and then I clean the board. Okay. Awesome. Not sure what happened there. All right. So after we're done here, we're going to do the initial test with our multimeters. So this is on page 6. Oh, I have made a mistake. I see that the very first thing here says do not install the integrated circuit into its socket yet. So I'm sorry about that. Please take that out. And I'll just go ahead and remove it on here to show you how to do it. Sometimes I get a pair of pliers. It tends to be a little better than my hands. So if I have to remove it, I'm going to use the pair of pliers and just slowly pull up on one side. And then you go to the other side. You get it just a little bit lifted, and then you slowly lift it up on the other side. So this is good practice to learn how to do this, because it is important to be able to remove these. And if you have like a little screwdriver, you can put that underneath there too. Awesome. It's like really on there. Get a little screwdriver. Yeah, the screwdriver works a little better than the pliers. So you just kind of slowly work up each end. There you go. It's coming up now. Yeah, screwdriver works really good. And then I'm going to put it back into that black foam that it came in. So it's ready to use for the next time. So that's the screwdriver I used. Okay. So it says that you're going to connect the negative lead of your multimeter to the negative terminal of the battery holder. So you can look, if you look inside of here, you can see that there are underneath here, there are indications underneath the little metal contacts of plus and minus. So I'm gonna check the chat window here just because I see some stuff. And yeah, just the bottom is the board that I, as was mentioned, only clean the bottom of the board. Okay, so it says to probe the following circuit points with a positive lead of the multimeter and record the resistance measured. The expected values in the table below are only rough estimates, so don't be concerned if your measurements differ by as much as a factor of 2 from these nominal values. So whenever so here you see that this says U1 through U7 and then all the way through U14. So back to our pin 1 indicator, I think we've probably gone over pin 1 so many times now, so I hope that it's really clear. But pin 1 is here, and if you're still unsure, you can flip it over, and so you can see my board's actually still sticky, so really I need to go back and clean this again. And I'm actually going to do this on the completed board since let's see. Hold on one second. Let me pull this off because this happens to be another board that we have sitting here. So we'll see how they did. Okay, so let's just be clear about what it is. When this is calling out U1 pin 1, then it's going to be right here, but that's what I was trying to tell you, is if you want to turn it around and check, it's also the one that is a square. If you look really closely at these, there will be a square, and then the rest of them will be circles. So again, the square indicates pin 1. And the pin out, what we call the pin out, and that's how these chips are wired, is pin 1, 2, 3, 4, 5, 6, 7, and then it cuts across 8, 9, 10, 11, 12, 13, 14. Okay, so it kind of comes around like that. So it's important to understand that. So again, we are measuring from, I'm gonna zoom out so we can see what I'm doing. On. Okay. So negative terminal here, I've got my lead on the metal part of it. And then I've got the meter set to, so I see that the expected value here is the 100K. So I'm going to put this on the 200K dial, part of the dial. As we found out last week, it's important to push the plugs, these plugs in all the way, or else it won't read anything. And I'm just going to measure it. And so it's saying it should be about, sorry. So this is saying it should be about 100K, and it appears to be moving. There must be a little bit of, well, it's staying solid at 111K. So that's good. That's what it says it's expected. So U2 should be also greater than that. And it is, it's 135 or 38 ohms, kilo ohms, sorry. Okay, and then U1 and U13, we have, I guess I have to do that. Go to the next position, and sorry, we're going to 3. So it's not showing anything. I assume that that is correct. So when we get to 1 meg, it's pretty high. Let me just get my other meter out and check this.
For those who are unable to use a higher sensitivity multimeter, what you can do is set it to the highest reading on that red multimeter that you can. And what you should expect there is it to, if it doesn't read 1 meg, it should just void out where you have that 1 floating. But it should go, you should flick through a couple of numbers and then hit the, just show a 1.
Yeah, even on here, I assume it's basically like an open right there. I'd have to go back and look. What's the schematic? Okay. So U1, yeah, 1 meg is getting is a pretty high resistance. So it's not an open, what we call an open, meaning that, you know, this is like having 2 leads apart. That's definitely not going to read any resistance, right? But so 1 meg is but it's a pretty high resistance. So not quite an open circuit, but yeah. Okay, so U14 is 10K, so I'm going to go back down. So yes, 10K, okay, cool. And then U15, so I expect again this is probably going to be that open that we saw earlier. Yeah, it kind of read something and then went away. U16 is 100K. So we know it's, let's see, I think it's a 14 pin. So if it's 14 pins across, then we know the last one is pin 7. I mean pin 6. The second to last is pin 6. So yes, that's greater than 100K. And then U17 is less than 10 ohms. That must be pretty close to a ground connection. I would expect that to be ground right there. Yeah, so it's 0.7 ohms. So I'm going to let you guys fill out the rest of it, but if you, well, I'll just do one more just in case it wasn't clear. So I'm here on U8, and that's supposed to be the 25K, and so I'm going to come, this is pin 8, so yeah, 25, 27K. Okay, so, and then you just work your way back up for that. So I'm curious if anybody is doing this right now. Can you tell me if you're without the thermistor, because maybe you didn't finish it, are your values close to what it says on the paper?
The ones that I'm getting are, but also I'm not measuring anything for the 3rd pin.
Okay, yeah, I think that's right for the 3rd pin. I mean, it's, I think it's just above the value of the meter. So has anybody else tried? All right, well, I'm going to move on, but it's no problem. I know everybody's sort of at different levels of putting this together, and that's no problem at all. So hopefully you kind of saw me go through it and how to switch that dial on the meter and to be able to get the values. So I would expect looking on here that U13, 5, 9, and 11, those pins are probably, you're going to put it on the highest setting and it's still not going to read anything. So just expect that. And I'm just, because I'm curious right now, I'm going to go back to the schematic and look at what is connected there. So we're looking at 3, 5, 9, and 11. So let's look. It's some capacitors, 3, 5, 9 is the output of the speaker. Interesting. It's just, yeah, I'm surprised the speaker isn't showing. Oh, but it's got the capacitor there. Yeah. Okay. Cool. Thanks for the feedback, Charles. Good to know. So it sounds like some of the number, like this exercise will still work, even if you don't have your thermistor connected. So I would say, you know, if you've gotten through all the soldering, go ahead and go through this exercise, and then you can go back and check it one more time once you get the thermistor through. It really doesn't take that long to go do. Okay, so now we're going to, and this is a really great exercise and why you should not have that integrated circuit into the socket. And I forgot about this. So because we have the socket, this allows us to basically power the board on without having this kind of very sensitive circuit chip in there. So basically, if something is wrong, we're not going to damage it. So it says, go ahead and install the battery. So I'm hoping also that everybody has a 9-volt battery. That's something that should have been, maybe your advisor should have given you with your kits. So hopefully you do have that. So there, on the battery itself, there is a plus and minus side. You can see those are different. They're different for a reason. And this particular battery holder is really not what we call keyed. So probably if you've ever plugged in a 9-volt battery into something, oftentimes there's a specific, like what you plug into is very obvious which one of these two plugs should go somewhere. But for this one, it doesn't have that. So it's real easy to get this in backwards. So it's important for you to understand how to mate up the plus and negative. So there is a positive sign on one side. It's kind of the smaller of the two terminals. And then there is also the negative sign here. And then if you look inside the, right underneath the metal contacts, as I mentioned earlier, there is a plus and a negative sign associated there. So you can line those up. And I'm going to go ahead and put the plus sign. It's going to be closer to this side here. Now, if you do get it wrong, if you remember and you go back and look at the circuit, so hold on a second, let me get this in. It's pretty tight. Okay, so the best way to do it, because I just struggled with it, is to slide it from the back side and then put it in. And you might have to kind of push out here, but then it should go in. And just make sure it connects. It's making contact. Yeah, and you can slip it in. So slide it in from the back. Don't just try to shove it in the top like I did and failed. All right. So the first thing I'm going to check is whether, probably could have done that before plugging it in, but I'm going to just check to make sure that we actually have 9 volts on the battery. So I am putting this on the 20 and then going to just check that real quick, and it does look like it's 9.64 volts. So awesome. Back to what I was saying is if you were to plug this in backwards, I don't know if you remember from before, but there is this diode that is here, and that diode is a battery protection diode. So whenever if you were to install this backwards, then basically current will not flow through the circuit because of that. Again, if you're designing a board or any kind of setup or something, a wiring harness, maybe the board itself doesn't have, you know, the diode on the board, you could install a diode in line with the cable, different ways to do that. So just something to think about for the future when you might be designing a system. All right, so let's read the instructions. Let's see. Plus terminal of night is the smaller of the two. Okay, no on-off switch. I don't know where the on-off switch is exactly, so we'll just see how this goes. All right, so we're going to hold the negative part to the black lead of the to the negative of the battery terminal, and then verify voltage across. Okay. So hopefully you can see this. So again, going back to U1, I know where pin 1 is. So I'm just going to check this here. Okay. So it's not quite at 9 volts, but it is 8.2 volts. Not sure why that's a little different. I'm a little confused as to... Okay, so that one is 7 volts. Not quite 9. Oh, sorry, that's the... I made the mistake of thinking that was pin 8. It's not pin 8. The pin 8 is down below. There we go. So now it's pretty close. Okay, great. Look at those and just see. Those are a little off than what they're supposed to be. It's a little confusing to me, so I'm just going to look at the schematic. Oh, okay. Well, pin 1 is connected through the photodiode, so that's probably the reason why it is getting a weird value. If you saw it, it should have been closer to 9, but that resistance, there's probably a voltage divider or something there. Well, okay.
Jill, isn't it just the regular diode that's causing the drop?
Yes, thank you. Oh my gosh, I just said that. That's exactly the problem. Thank you. Yeah, so as she mentioned, the current is going through the diode. As I'm probing on this, I'm creating a circuit, and so there is typically those things have like a 0.7 voltage drop, which is about what we were seeing. So yeah. But if you are seeing something that isn't quite right to what is, you know, stated or what you think, yeah, definitely you have to kind of stop and look into that and figure out what why that is the case. So that's why I was kind of trying to look at the schematic here. So I'm just going to point it out here since I have it and I'm examining it myself. You've got the 9 volts and it's going through this diode. So as I'm connecting sort of the circuit together with this multimeter, there's a voltage drop because this diode has an internal resistance. And so as current flows through it, there is a voltage drop across that component. I'm pretty sure if I remember correctly, diodes typically have a 26 ohm resistance. So, okay, awesome. That was confusing. Okay, so we're going to remove that battery now, and you're going to install the IC chip back into the part, into the socket. So the same thing, you just want to be really careful. I tend to put it into one side, kind of get it a little bit aligned, and then I go to the other side. I get it sort of situated. I make sure I've got pin 1 correct, and then I push it down. And in case you missed it earlier, I use the screwdriver, if you were to remove it, to gently pull up on each of these sides and just slowly work it back and forth. Okay, I'm going to get this board out because I know this one works. So chips in, now we're going to go ahead and install the battery into the socket. Let's see, I'm sorry, into the battery holder. Let's see, I'm just looking at the notes here. So as I put the battery back in, I am aligning it to make sure the positive and the negative are in there. All right, and hopefully this is what you will see. So for those people who don't have the thermistor made, but you have all the soldering finished, if I remove the thermistor here, you still will get something. And if I block this, it should slow it down or really slow it down a lot. And if I install this, you're going to hear a different frequency. And if you want, you can test it out. So hopefully you guys are hearing it. I'm not sure, but you can heat up the thermistor with your finger and you should hear also a different frequency. And then if I cover the photo sensor, it should slow down significantly. And then as I let this off, it's cooling back off and you should hear it change again.
And just so that you're aware, yeah, we can hear the
the beep.
Here.
Great. That's good. Just having a little beep choke to myself over here. All right. That is the end of what we're going to do today.